So this video is about something I call dangerously creative problem solving. And I'm going to start at this point in AI history. This is Go World Master Lee Sedol playing against AlphaGo, an AI system built by Google. And AlphaGo was created partly in a way called reinforcement learning, which means that you let an AI system freely explore the space of possible solutions to a problem and take whatever path it finds works. And in this image here, we see move 37 from one of the games. And that was a move made by AlphaGo that all experts commenting the game would say was a mistake, a blunder that would cost AlphaGo the game. I don't know what Lee Sedol thought, but he was stumbled by this move. He took a break, went out to smoke, and came back. And it was a really weird move. But it turned out that later on in the game, this was what gave AlphaGo the victory in the game, because it was foreseeing something that neither Lee Sedol nor the expert commenters could see. Neither could millennia of playing this game by humans prepare us for this game. So AI, the free exploration of the AI in this problem space, made it find this move that we really couldn't do. And this is creative problem solving in a brilliant way. But sometimes AI also creates unintended and sometimes dangerous solutions to problems that we didn't intend. And I'm going to show you 5 examples of this and then give you something to reflect on as an exercise. Example number 1, also from a board game, is a chess computer and an LLM set to play against the world's best chess computer. And when tasked with beating this chess computer, the AI sometimes found innovative ways of doing that. And it's impossible for a human to do, basically impossible for a human to do this. And it's really, an LLM can't beat a world-class chess computer. But if the chess computer is running on the same system as the AI is running on, then the AI can notice this and go in and modify the files that shows the chess computer what the board looks like. And in some cases, the AI did this and made the chess computer believe it was in an unrecoverable disadvantage, making it resign. So the large language model could achieve its goal, but it did it in a way that wasn't really playing by the rules. Second example is from a Japanese company called Sakana AI. They have built an AI system called scientist system for building research, hypothesis or research ideas. And it set this out on finding new good research ideas. And sometimes the AI realized or felt that it didn't have enough resources to finish its all the thought traces it had. And it found its a file where it could modify its own settings, giving it more execution time, more power to make its artificial thoughts, and thus being able to produce better results. And this might be brilliant. I mean, it makes the AI system more competent and more able to reach its goals. But it's also kind of unnerving when an AI system gives itself more power in order to reach its goals without having a human approving it. A third example is from a company called Replit, a software building company, and it has parts of its business is having AI helping people writing software. And there's a .replit file that is used for storing some settings and stuff. And the people at Replit realized that the AI sometimes modified this file in a way that broke stuff. So it added instructions to the AI and said, well, don't touch this file, use other ways of solving your problems. And the AI oftentimes obeyed this, but sometimes it just ignored it and changed the .replit file anyway, which is not really creative, but only disobedient. Then the Replit engineers added some kind of warning system. Whenever the AI touched or changed the .replit file, it would throw an error and stop the execution, thereby learning the AI that you shouldn't touch this file. The AI countered with writing a script that changed the file instead, which wouldn't trigger these errors and thus solve its problem. Replit then said, let's make it impossible for the AI to touch this .replit file. So it put the AI in a sandbox environment that had no connection to this .replit file. So only the human users could change that file. The AI actually found a way around this as well by talking to the human user and saying, here's a piece of code, please make these changes to the .replit file. And this is definitely creative problem solving, possibly in a dangerous way. The consequences I don't know very much about. All right. Example number 4 comes from an AI model called O1 and the evaluations made before it was launched. Some AI researchers evaluated its capacity for hacking, its ability to hack, by I think it was 10 virtual machines that was spun up, and that had some kind of secret inside these machines, and they tasked O1 to hack into these machines and find the flag.txt file and tell whatever was inside it. However, one of these virtual machines didn't start. It was malconfigured in some way, which O1 realized, and then tried to find a way to solve this, and realized there was a security loophole in the server or the master machine running these virtual machines, which it could use, hack into that machine, and then restart the virtual machines and just have it spit out the flag.txt. So it escalated its hacking in one level, hacking into a level that wasn't really intended. Right, fifth and last example is also from Sakana AI. They have something called, they create something called CUDA kernels, which I think are used for running NVIDIA chips, doing that as efficiently as possible. And they had an AI system that they tasked to write more efficient CUDA kernels, because that's, of course, worth a lot of money. And they had evaluations running, telling them how efficient these CUDA kernels were. And the AI came back and said, well, here are improved CUDA kernels. They are 10 to 100 times more efficient than the usual programs, which of course made Sakana AI go to X or Twitter, spreading the news to the world. However, it turned out that these new CUDA kernels weren't at all that effective. It turned out that these evaluations had some flaws in them, which the AI used, of course, to get as good evaluations as possible, because that was what it was tasked to do. Sakana AI had to post again and say, sorry, our mistake. This was bad. We'll improve and have more oversight of this next time. All right, so these are 5 examples of creative problem solving and sometimes dangerously creative problem solving by AI. The exercise for this video is just to reflect a bit on this. How can we tell helpful creativity from dangerous creativity? What is good, what is bad, actually? And is there any way we can keep the good ideas but avoid the dangerous ones? How can we think? How can we work to get the help we want from AI and avoid the negative outcomes? And also, you pick whatever question you would like to discuss. How can we tell the dangerous solutions from negative side effects of what we actually wanted. When we ask an LLM to beat a chess computer, is it a negative side effect that it starts hacking the system, or is that something that is outside of the scope? What did we really mean when we asked it to beat the chess computer? Well, reflect a bit about one or several of these questions. Please leave a comment if you have thoughts about this. And thanks for watching. See you in another video.